Okay, so we're going to take a derivative of this. This is a derivative of an integral. This is the fundamental theorem of calculus, right? So remember what happens is this comes in here, right? So this is just going to be equal to sine of x squared cubed times the derivative of the x squared, 2x. Okay, so that's 2x sine x to the 6, which is e. Okay, all right. Other ones, 22. The graph of f prime, right? The derivative of f is the line shown below. Again, highlight, highlight. So this is f prime, derivative, slope, whatever. If f of 0 is 5, then what's f of 1? Okay, so this is a line, right? And it tells you it's a line, so there is no, question about it. And we know that f of 0 is 5, and the y-intercept is 6, so we can come up with an equation for this, right? What is the equation for this? So this is f prime, which is dy dx, and this is what? Negative 6x plus 6, right? Because the slope is down 6 over 1. So I'm just writing an equation of this line, algebra 1 style, okay? You have a line here. What's the equation of this? Well, the slope is negative 6. The y-intercept is that, okay? And now what I want is f of 1. In order for me to figure out what f of 1 is, I need y. I need the function. I need f of x, okay? So let's do separation of variables. Take an integral. So I get that y is equal to, okay, negative 6x squared over 2 plus 6x plus c. Okay, let's put in our initial condition. When x is 0, y is 5. So 5 equals negative 3 times 0 plus c. C is equal to 5. Okay? All right, so if c is equal to 5, then what's y equal to? Y is equal to negative 3x squared plus 6x plus 5. And then, so f of 1 will be negative 3 times 1 squared plus 6 times 1 plus 5. And that's, what is that? 11 minus 3, 8.
Yeah, that's right.
You can do that, but that's I found like this is easier for a lot of students to, because it's more like systematic. Okay? Yeah.
So the area will still work.
Yeah.
Okay.
Okay? Yep.
Can you
19.
Yeah.
Okay. Okay. A curve has slope 2x plus 3 at each point. Which of the following is an equation for this curve? If it passes through the point 1, 2. Okay, so it's the same exact thing that we just did for the other one, right? Number 19. Because the slope is 2x plus 3. So dy dx is 2x plus 3. But I want y. Yeah, oh, sorry. But I want y, okay? So this is the initial condition, 1, 2. All right, so dy is 2x plus 3 dx. Y is x squared plus, you integrate, of course, x squared plus 3x plus c. Put in the 1, 2, so y is 2 when we have 1 plus 3 plus c. C is negative 2. So y is x squared plus 3x minus 2, D. Okay? So if you're like lost when you read this problem, okay, the benefit of it being a multiple choice question versus an FRQ is you look at all the answers. You're given slope and your answers are in y equals. So you're like, okay, slope is y prime or dy dx. This is y equals. So that could give you a hint that you should like take an integral of some sort. Yeah.
Can you remind me what like separation of dy dx and then integral? Like, what does it give you?
The function. So suppose I have a function x squared plus 3.
Okay.
Yeah? Y prime is 2x, right?
And we had a way before to find that too, right? Like
This was it.
A long method?
This was it. It seemed longer to you then. This was it. There was no other.
Beginning of the year. Beginning of the year. Didn't we do something that also we had to do f of something minus like
Okay, so that is a different thing. That was the definition of the derivative. Yeah. Okay. Other questions? Yes. What is the slope of the line tangent to this curve at the point 3, 2? So tangent meaning we need to find just the slope of the line tangent to this. So we need to find y prime evaluated at this point, okay? And then, all right, so let's do this one and then maybe we can move on to some FRQs, all right? So how are we going to take a derivative of this? This is an implicit function. You can't solve this for y explicitly. So it's going to be an implicit differentiation problem. So this first one, take the derivative is 6y dy dx, okay? Minus 4x equal to 0. Okay, now here I have minus, and this is what I need to do product rule on. So 2x times dy dx plus 2y. Okay? Now, bring all the dy dx's to the same side. So this is going to be 6y dy dx plus 2x dy dx is equal to 4x minus 2y. Dy dx can be factored out, and I get 6y plus 2x is 4x minus 2y. So dy dx is 4x minus 2y over 6y plus 2x. And now I need to evaluate that at the point 3, 2. Okay. Sorry, 6y, sorry. It's 6 times 2, 2 times 3. And that's 8 over 18, which is B. Okay? All right. I'll take one more question, and then I'm going to do the FRQs. Yeah.
If someone has a different method, I was thinking that we could do 16 and 17. How much? 16 and 17.
Okay, so why don't we do 17, and then I have the full solutions to this on my JAG as of this morning. You can go ahead and take a look at 16. So let's do 17. Okay, let f be this function. The graph of f is concave down when what happens? So concave down is when f double prime of x is less than 0, right? So we need to find f double prime of x. So for these questions, always ask yourself, okay, what am I being asked? What does that mean? And that will, okay? It's like a database, concave down. Okay, f double prime less than 0. All right, so f prime of x, we got to do the chain rule. So u prime v, 2 e to the x, I'm sorry, product rule, plus 2x e to the x. F double prime of x is 2 e to the x plus, we need to take a derivative of this again, right? And look, do you see how it's like you got the same function back here? And now you need to take a derivative of it. So you already done it. So just copy it over. It's like this, you know, cute little recursive thing. Okay? So if it's not an emergency, let's not text right now. Okay. Yes. Okay. So what's this? 4e to the x, right? This gives you 4e to the x plus 2x e to the x. Okay? Now, we want this to be equal to 0. Right? Okay. So, how is that going to happen? So look at this one. Do you see how we can factor out an e to the x and also a 2? Yeah. Let's do that. So 0 equals 2 e to the x, 2 plus x. Okay? Now, can e to the x ever be 0? No. But 2 plus x can at negative 2. All right? And now, after negative 2, this whole thing is positive, right? And before negative 2, it's negative, so this is concave down at A. Yep. Okay, so I do have the solutions, like the full solutions to this on MyJack, so go ahead and take a look. For tonight, I want you to do the other part to this. What were the numbers? All right, so part B of this 2019 exam says the region R is the base of a solid. For the solid, at each x, the cross-section perpendicular to the x-axis has area of this. Find the volume of the solid. So this is actually a simpler version of all those cross-section problems that we used to do. Because before, the problems would say, you know, each cross-section is a square or a triangle with a base here and a hypotenuse there. And you yourself had to find the area, right? Here, they're giving you the area and you have to find the volume. So in those problems, after you found the area, what did you have to do to it to find the volume? Integral. Well, here they're giving you the integral. So you're just going to say, okay, B, the volume is the integral from 0 to, what was it, 2? 1 over x plus 3 dx. Okay, but this is a, what do you call it? This is a non-calculator problem, so we have to do this by hand. Okay, so let's do u substitution. U is x plus 3. Du is 1 dx, right? So this is going to be 1 over u du, okay? And what are the bounds? It's 3 to 5. And this is going to be ln of u from 3 to 5, ln of 5 minus ln of 3, and you can leave your answer like that. This is a 2-point question, one for showing the correct integral, one for this. Now, do you have to do u substitution here? No. Some of you might just be able to do it like without u substitution. Totally fine. Does it matter? Do you get a different answer? No. And it's, you know, just get your points however you want to get your points. Okay? All right. C says to write but not evaluate an integral expression that gives the volume of the solid generated when R is rotated around the horizontal line, y equals 6. My. Right here. Okay, so we're rotating around that. Okay, so what do we have to write? Big R, little r. Yeah? Okay, remember, what is the axis of revolution? 6. So radius goes from axis out to the curve, right? And it's got to be top minus bottom. So from axis out to the curve, from axis out to the curve. Okay? So big R is the red one over there, and it's going to be, 6 minus g of x, top minus bottom. All right? So for part C, it's going to be v is pi times the integral from 0 to 2, 6 minus g of x squared minus, what's the little r? 6 minus h of x squared dx. Okay?
You don't have to put the actual function.
No, you're...
Like that, is that it?
That's it. Because look, it says write, but do not evaluate. Now, g of x and h of x are functions that they gave you. They know what the functions are. They told you what the functions are. You don't have to do anything more than that. So, and this is a 3-point problem. So here we go. We get 1 point for the limits and the constant. So these together are 1 point. Okay? 1 point.
How do you know it's 0 to 2?
Because it's always like from here, 0 to 2. Yeah? You get 1 point for the form of the integrand, and then 1 point for the actual integrand. So form of the integrand, so basically it's 2 points for this. So basically they'll give you 1 point for, having top minus bottom, squared, and then, for having the functions in the right place. Yeah.
Just as a reminder for myself, you
Yep.
always subtract the line, so 6 minus the big R and then square and minus everything.
If the line is on top. So,
Oh, right.
right.
The
So,
opposite.
okay, yeah. So the thing is, what's the axis of revolution? Radius goes from the axis out to the curve, and then you do top minus bottom. Okay? So whatever is on top, whatever's on the bottom. But yes, it's the difference between the two.
Right minus left.
Or right minus left. Right. Okay. All right. Okay, so next one. Functions f, g, and h are twice differentiable, with g of 2 equal to h of 2. Oh, yes, I remember this one. Equal to 4. Okay? I remember this one. Yeah. Okay. The line, blah, is tangent to both the graph of g at x equals 2 and h at x equals 2. Okay, what does that mean? So here's that line, 4 plus 2 over 3, x minus 2. So this is like a positive slope, right? It's an increasing line. So basically, I don't know what g of x looks like. I don't know what h of x looks like. But suppose, this was g of x. This is at 2. So suppose this is g of x at 2. The line is tangent to it. Okay? That's why. Do you see how it's tangent to it at x equals 2? And now, h of x is a completely different function, but h of x is over there, and that line, that purple line, is also tangent to h of x at that same point, right? So if one line is tangent to two graphs at the same point, what does it tell you about what's happening to the two graphs at that point? They're intersecting, they're touching at that point, right? And it also tells you that because it says g of 2 and h of 2 is 4. So this is the, this is happening at 4, okay? All right. So I want h prime of 2. I want the slope of h at 2. What is the slope of h at 2? Huh?
The tangent one?
It's the slope of the tangent line. Yes, it's the slope of the tangent line. And what's the slope of the tangent line here? 2 over 3. So h prime of 2 is 2 over 3. No work for this one.
That's cash.
That's cash, and it's also plus 1. You just put a point in your pocket. Way to go. Whew. All right, listen. Sometimes, like 1 plus 1 plus 1 a couple times, that's a whole lot of points, okay? Yeah. And if part 1 was that easy, B, C, and D, something's coming in B, C, or D, right? Okay, so let's do B. Let A be the function given by this lovely thing. Write an expression for A prime of x and find A prime of 2. Oh, I can totally do that. Okay, so A prime of x is the derivative of this, but you see how I'm going to do product rule? Okay, so A prime of x is u prime 9x squared v plus u v prime. A prime of 2 is 9 times 4 times h of 2 plus 3 times 8 h prime of 2. Oh, that's why they made us find h prime of 2. So this is equal to 9 times 4. What's h of 2? 4, they tell you up there, plus 24 times 2/3, and all that is equal to 160. Okay, remember you have to do that calculation without a calculator. And so, this gives you a good idea also of what type of calculations you're going to have. So you're not going to have to do like 18.5 times 7.3, nothing like that. But this, it's all good stuff here. Okay. The function h satisfies this equation for x not equal to 2. It is known that the limit can be evaluated as x approaches 2, can be evaluated using L'Hopital's rule. What does that tell you if you can use L'Hopital's rule? That it's 0 over 0. Okay? Okay. Use the limit as x approaches 2 of h of x to find f of 2 and f prime of 2. Okay, so let's do it. Oh, you know what? Let me do points here. So you get 1 point here for the product rule. You get 1 point for doing the product rule, and then 1 point for doing it, for finding a prime of x correctly, right? Like no errors or whatever. And then 1 point for this. So 3 points for that. Okay? All right. So here, what is f of 2 in this case? Okay, so if we use L'Hopital's rule, that means the limit as x approaches 2 of 1 minus f of x cubed should equal to 0. Yes? So the denominator as x approaches 2, it should equal 0, right? Because you guys just said it means 0 over 0. So that means at f of 2, that means when this is 2, right? F of 2 should equal 1. Right? Because the only way to get 0 here is if this was 1. Does that make sense? Yes? Yes? Yes or no? No? Yes? Okay. What is it that we need to find here? Find f of 2 and f prime of 2. Okay, so we just found f of 2. So how are we going to find f prime of 2?
So are you plugging 2 to the one above?
Huh? So we're going to use L'Hopital's rule, right?
Yeah.
Okay, so what are we going to do?
So we use the quotient.
The limit as x approaches 2 of that, what would we get on top?
Negative.
So 2x on top, right? So we're going to use L'Hopital's rule on this because they said we can use L'Hopital's rule on this. So let's go ahead and use L'Hopital's rule on this, okay? So take a derivative of the top, right? That's what L'Hopital's rule says, and then take a derivative of the bottom. So taking a derivative of the top, I get 2x over 1 minus, negative 3 f of x squared times what? Times the derivative of the inside, f prime of x.
No, why would we do that, not like the quotient?
Because L'Hopital's rule, remember, is not just the derivative of the thing. L'Hopital's rule separates numerator from denominator into separate entities, and we just took a derivative of the top separately and the derivative of the bottom separately. Yeah, so it's a lot easier than that. So as x approaches 2, so let's plug in 2 in here. This is equal to 2 times 2 over negative 3 times 1
times f prime of 2.
Yeah, so this is f of 2 squared times f prime of 2. And what are all these numbers equal to? Huh? Okay, so this is equal to 4 over negative 3 times what's f of 2? 1 times f prime of 2. Do we know what that is? No. Okay, but what is this? This is the limit as x approaches 2 of h of x, correct? And what is the limit as x approaches 2 of h of x?
4.
It's equal to 4. Okay, so the limit as x approaches 2 is equal to 4. So that is equal to 4. And now we can go ahead and find it. So you can basically like divide these out. So 1 over negative 3 f prime of 2 is equal to 1. So f prime of 2 is negative a third. Okay, so let me tell you how the points were distributed here. You get 1 point for finding this, 1 point for L'Hopital's rule, 1 point for saying that L'Hopital's rule equals 4, and then 1 point for this. So that's 4 points. Yeah. It is known that g of x is less than or equal to h of x for 1 to 3. Let k be a function satisfying that it's between g of x and h of x for 1 to 3. Is k continuous at x equals 2? So basically, it's saying that from 1 to 3, g of x is less than h of x. So, if g of x looks like this, h of x probably looks like that, right? It's less. And then remember, this is the line that's tangent. Okay. Now, the question is asking, if there is another function k of x that's in between these two, does that also have to be continuous? What do you guys think? If there was another function in the middle here, does it have to be continuous at x equals 2? Let's think about it. All of the values of that red function have to be in between the two purple ones, right? Okay, at x equals 2, what's the value of g of x? Well, 4. At x equals 2, what's the value of h of x? 4. And if the value of the red one has to be in between those two, what's the only thing that it could be? 4. So it's got to be continuous because of that, because it's bound by the other two functions. All right? Because it says for every single number, g of x is in between, k of x is in between the other two. Okay? So it can't just be undefined or non-existent or something else. But how are you going to write that down? Okay? So you say since, okay, G and H are differentiable, it means they are what? Continuous. Okay?
How do you know the differential?
It says that they are. In the very first sentence, it says they are twice differentiable. Okay? Okay, so since they're differentiable, right, the limit as x, since they're continuous, it means the limit as x approaches 2 of g of x is equal to g of 2, which is 4. And the limit as x approaches 2 of h of x is the same as h of 2, which is 4. Okay? And then since, what was it here? G of 2 is less than or equal to h of 2 is less than or equal to, G of 2 is less than or equal to k of 2, less than or equal to h of 2, which is equal to 4, k of 2 is also 4, and it's continuous. Okay. And this is only 2 points for this one.
So the answer is just the